Okay, so we looked at when triangles are congruent. Now we'll look at when they are similar. Okay, so similar triangles is a little bit different in that, if I give you the definition, you'll see similar triangles. Triangles, this is the definition. Triangles are similar. So in other words, two triangles are similar if they have corresponding sides in proportion. Okay, so for example, you might have, like, if we talk about in proportion, we might have a small person, okay, and a big person, and they're in proportion because the head, for example, is twice or half the size of the body, things like that. Okay, so triangles are in proportion, and again, it is based, it's not about that they're exactly the same, but for example, this triangle would be in proportion to this triangle. That's an example. Now, why? Okay, remember what we said before. Proportion is about that fraction, comparing sides and finding the same ratio. Yes. So in other words, if I have these two triangles, and we find that if I take AB and I divide it with DE, I'll get the same answer than if I take AC and divide it by DF. You see, I'm dividing sides that are corresponding sides with each other. Now, the order in which you do this doesn't matter. You can, for example, you can say, I want to take AB divided by AC. And look what I did. I just divided both sides with AC. On this side, it cancels. You see, if I divide this side with AC and this side with AC, this side cancels. And now I've got AB over AC. And I also divide both sides with DE. Then I get on this side, I multiply both sides with DE. So I multiply both sides with the DE, and I divide both sides with AC. Now this side it cancels, this side this cancels, and I end up having DE over DF. Okay, look here, DE over DF. Okay, but look at what it looks like on the picture. If I take this side divided by this side, I'll get the same answer as if I take this side, DE, divided by DF. Understand? It doesn't matter in which order you do it. Okay, so you can literally take any order. I can take AB divided by, so I take this side divided by that side, DF. As long as I now take the corresponding this side divided by this side, AC, divided by DE. So as long as you keep the, I don't know how to say this, but the order in which you choose the one fraction should be the order in which you choose the other fraction. If you choose 2 from this one, you should choose the 2 corresponding from this one. If you choose 1 from this one and 1 from that one on the other side, you must choose another one from this one and the corresponding other one from that one. Okay, so there's a lot of different combinations you can make, and this is very, 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 very powerful. Okay, so Similar triangles, as I said, is almost like congruent triangles, but in congruent triangles was when we had three sides, it was congruent. This time it's similar if they are in proportion. But to prove similarity, to show that two things are similar, we can just show that they have three angles in common. So if we have three angles, this angle is equal to that angle, this angle, these two angles are the same, and this angle is equal to that angle. We call this equiangular. If we have two equiangular triangles, they will be similar. And that is going to be the next proof we're going to look at. Also a quite intense proof. So that's our theorem. Two equiangular triangles are similar. Okay, so remember what it means. Similar means that I can take the sides, the ratio of the sides, and I'll get the same answer. That's what similar means. Equiangular triangles means I've got two triangles and their corresponding angles are equal. Okay, so to prove, so we're going to prove this, we'll draw our two equiangular triangles. Draw one large one and one that looks almost the same but smaller. Call one A, B, C, and the other one, well, it doesn't matter what you call them, D, E, F. I'm going to call it D, E, F. And now I'll give you more or less the outline of this proof. First, what we're going to do is we are going to construct another triangle on here. Triangle PQ. And we're going to show that, so first we're going to show that triangle APQ is congruent to triangle DEF. So we're going to draw this triangle congruent to that triangle. Now, if they are congruent, the second thing that we're going to show is that PQ is parallel to BC. So we're going to show that PQ is parallel to BC. And now we can use the previous theorem that we had. Remember, the previous theorem said that if I have a line parallel to this one, then the sides are in proportion. And we'll use that side, and because this is congruent to that one, we can just replace the proportion, the sides that's in proportion with DE, for example, instead of AP. And then we'll have what we want. Okay, so that's the outline. So the third thing we'll do is we'll use the proportion theorem. That was the previous theorem. That was the previous theorem we learned. Okay, so to prove, okay, we want to prove that DE divided by AB is equal to DF divided by AC. We'll have only one construction. That makes this one a little bit simpler. We'll construct point P so that Actually, let's say construct point P on AB. So P didn't exist there, remember? I drew it in now. Okay, so we draw P on AB so that AP is equal to DE. Now just remember that I didn't put it in here, but that we said we have equiangular triangles. That means that A and D is equal, B and E is equal, and C and F is equal. And that's given because we have equiangular triangles. I just forgot to mention that. Okay, so the next construction is that we are drawing Q on AC so that AQ is equal to DF. Okay, let's pause here and make sure that you understand exactly what I've done so far. So now my first step is going to be to prove that this triangle, this little triangle here, is congruent to that triangle there. Okay, so all I know so far is that AP is equal to DE. Why? Why is AP equal to DE?
Corresponding angles.
No, it's not even an angle, it's a side. No, it's the same because I drew it like that. I chose P. I'm putting P there so that it's true. I'll measure this distance and I'll make it the same distance there. You don't have to do it literally with a ruler. We're just saying let P be like that. You don't have to draw on scale. And in the same sense, I'm saying let Q be somewhere on AC so that DF and AQ is the same distance. So I just made this the same distance as that, and this the same distance as that, and now I'm going to prove that this constructed triangle that I drew is congruent to that one. Make sense? Okay, so in triangle APQ and triangle DEF, how about you guys show me how APQ and DEF is congruent? So in these two triangles we've got two sides that correspond and the inclusive angle that corresponds. So we're going to do side, angle, side. Okay, so we'll do it in that order as well. 1, okay, AP is equal to DE. Why? Why is AP equal to DE?
Because AP is given.
It's not given. Constructed by construction. We drew it like that. It's our fault. By construction. 2. Angle A is equal to angle D. Why? That was given because we know they are equiangular. And 3, that's the third, there's the second side. We've done side, angle, the second side. We have that AQ is equal to DF. Why is AQ equal to DF? Construction again, by construction. Okay, remember you get a mark for every step with a reason. If it should have a reason and you don't put a reason, you don't get the mark. Okay. So now we can say triangle APQ is congruent to triangle DEF. Remember the order is important. And what reason would I put here?
Side angle.
No?
Side angle. Angles.
Side angle side.
Oh,
Side angle side. Okay.
you always have to put it in that order.
Yes, you can't put it in another order because there's not the order in this case is important. In this case, the order is that's the only time that order is important. The other times it's not important. Okay. Now, why did we actually do this? We did it so that we can say that angle P is equal to angle E. And I want angle P to be equal to angle E because I know E is equal to B. That means these two are equal. And what letter of fun do you see here?
It's U. It is. No.
No.
It's
There's the parallel lines. Okay, so remember fun, you guys are going to study this now, so then you remember it.
F.
If U is for the, exactly, U is co-interior, and this is not a U because we're not using them on the same, on the interior of the parallel lines. Okay, so this is the F, that is corresponding. Again, corresponding just means I can move this one down and that angle will correspond to that angle. Okay, so that's how I'm going to show that they're parallel, because I find that corresponding angles are equal. It means they have to be parallel. Okay, so my first step was done. Now the second step is to show that they are parallel. So I'll say angle APQ is equal to angle DEF. Okay. So I've got APQ is equal to DEF. Why is APQ equal to DEF? Why is APQ? Why is this angle now all of a sudden equal to that angle? They're congruent. Well done. So if I make a statement, I give a reason from congruence. Okay. Okay. And now I'm going to say, but angle DEF is equal to angle ABC. So tell me that. Why is this angle equal to that angle?
Because the corresponding angles. If that is congruent with that,
ABC is not congruent to DEF.
Since APQ is equal to DEF and P is corresponding to B.
We don't know it's corresponding yet. That's what we're trying to prove. We're trying to prove it's corresponding. So we're doing it the other way around. It's easier than that, guys. Which was my original triangle? ABC and DEF.
So, since the similar.
No, they are equiangular. They have equal angles. That was given. The angles are equal to begin with. Okay, so why is DEF equal to ABC? That was given. We know that the original triangles had the same angles. Make sense? Okay, but now I've shown that APQ is equal to DEF, but DEF is equal to ABC. That means that these two must be equal, isn't it? Because they all both equal to the same thing. That's called, it's a law of logic. It means excluding the middle. Okay, if this one is equal to the middle, and the middle is, if the left is equal to the right, no, if the left is equal to the middle, and the middle is equal to the right, then it means the left is equal to the right. Okay, let me put it like this. if APQ is equal to DEF and DEF is equal to ABC,
Oh, then they.
you see, if this one is equal to the middle and the middle is equal to the right, then I can exclude the middle. I can say that these two are equal to each other. Okay. So in other words, so where am I now? Okay, so in other words, APQ is equal to ABC. That follows directly from this, so there's no reason given. It follows from this, from logic. Okay. And now I can say, therefore, okay, I've now shown that APQ, that this angle is equal to that angle. So I've shown that corresponding angles are equal. That means PQ must be parallel to BC. Does that make sense? So I've now shown that PQ is parallel to BC. And I can use corresponding angles as my reason. And now that I've shown that, I can use my proportion theorem. Because my proportion theorem says that if I have a side, a line drawn parallel to another side, it divides these sides proportionately. Okay? In other words, I can now say that, and proportionately, I can also, I don't have to say this divided by that. I can say this divided by that. Okay? It's proportionate. I can either take the part divided by another part or the whole divided by the part. It gives me the same answer. Okay? You guys don't trust me? Okay, let me prove it to you briefly. Or I tell you what, I'll if x plus y is equal to z. Let me rather do it here. If I do have space here. Okay. So if AP divided by PB is equal to AQ divided by QC, the question is it also true that the whole AP divided by AB, so I'm now taking the short one plus the long one, over the long one, is that also then equal to AQ over Q AC? Okay, now let me show you. AB is just AP plus PB, is it? So what I'm going to do here is I'm going to just turn them around. I'm going to say let this be AB over AP. I'm flipping the fraction, as long as I do it on both sides, that's fine. Okay, so AC over AQ. Okay, I'm just flipping it because it just makes it easier if I've got terms in the numerator. So I'm going to say AB is AP plus AQ plus PB. Okay, so there's the whole one is AP plus PB over AP is equal to, an AC is this AC is AQ plus QC. AQ plus QC over AQ. Okay, so now if I divide, remember if I have two terms divided by one term, I must distribute it. So I've got AP over AP plus PB over AP is equal to AQ over AQ. Oh, you believe me now? Oh, great. I like people not trusting me, by the way, because it means you are thinking. So this is going to divide and give me 1, and this is going to divide to give me 1. So I've got 1 on both sides, so I can subtract 1 and subtract 1. So I get rid of this and I get rid of that. So I have PB over AP is equal to QC over AQ. And if I flip them around again, AP over PB is equal to AQ over QC. And that's what I wanted to show. That if this is true, this is also true. AP over PB is equal to AQ over QC. Okay, so I'm glad we put that in. But so just to show you that if I have to use the proportion theorem, I don't just have to use this little bit divided by that little bit. I can use the whole one divided by one of the parts. Okay, it just makes more sense because I'm trying to use AB and I'm trying to use AP and substitute DE. Okay, you'll see just now what I mean. So in other words, I can now say that because of the proportion theorem, I can say that that top part, AP, divided by the whole line AB. Okay, I'll go to the sketch so you can see. AP, the top part, divided by the whole part is equal to the top part divided by the whole part. As long as you keep that, you should be fine. Okay, so it's equal to the top part, which is AQ, divided by the whole, which is AC. I'll go back just to show you. Top is AQ, divided by the whole, which is AC. Okay, so we know that. Why is that true? From the proportion theorem. This follows from the proportion theorem. And now I can just add but, because that's not what I'm trying to prove. I'm trying to prove that DE over AB, not PB, but AP should be DE, but AP is equal to DE. Why is AP equal to DE?
Because they are congruent triangles.
Congruent, or we constructed it like that. That was our original construction. So in other words, we can now go and replace it back. AP is equal to DE by construction or from congruence. And the same goes with AQ. AQ is equal to DF, also by construction or from congruence. So then we have that DE over AB is equal to DF over AC. And we've proven that equiangular triangles are similar.